Hey everybody. As you probably noticed by now, we're in a different setting than usual because actually this is my chemistry teacher's lab actually. So as I said, I was an IB graduate of 2019. From time to time, I still come back into the lab and help him out and stuff. So today I have this lab just teaching. Anyway, let's get on to the thing. So today, after covering the water crystallization, we've reached the final part of being able to apply mole calculations into more complex areas of quantitative chemistry, which this one is about empirical formulae. Okay, so you probably know empirical formula from IGCSE, but I just want to go through a recap anyway. So as you can see, here I've listed 3 different compounds. Okay, so we have butane, C4H10, we have glucose, C6H12O6, and ethanol, C2H5OH. Okay, so empirical formula basically means that the ratio between elements in a compound, as in these coefficients, these are, when they are simplified to their most basic terms, then that formula is considered empirical formulae. What do I mean by that? So let me just give you an example real quick. So butane has a structural formula of C4H10, okay? So the ratio between carbon to hydrogen is 4 to 10. So let me just write that down, 4 to 10. So if we were to simplify this ratio as much as possible, then we just divide both sides by 2, then we would have 2 to 5. So in this case, the empirical formula of butane would be C2H5. Okay? So that's basically how empirical formula works. Let's try another one. So glucose. Glucose, we have C6H12O6. Okay? So let's just write down the ratio real quick. Carbon to hydrogen to oxygen. So it's 6 to 12 to 6. Now, if we simplify this by dividing all sides by 6, then we would have 1 to 2 to 1. Okay? And then, thus the empirical formula here would be CH2O. Okay? Does that make sense so far? Okay, now I just want you to try this on your own. So just pause the video real quick and just try to jot down this one and try to deduce the empirical formula. Okay, so so now that you've tried it out, we're gonna just go through this one. So here we can see that the ratio between carbon, hydrogen, and oxygen is C2H6, okay, because there's 5 here and 1 over there. Don't forget this one. So it's 2 to 6 to 1, okay? Now, is there an empirical formula for this? No, because if you think about it, while 2 to 6, this ratio, only these 2 numbers here can be simplified further, the 1 cannot. So therefore ethanol is an empirical formula in itself. So now that I just kind of covered the concept, just a quick recap on empirical formula, I'm going to try out a few questions here. So these 2 questions are drawn from the IB syllabus in paper 1. So just kind of look through the question, copy them down, and we'll just go through them together. Okay? So first one we're going to do. So a hydrocarbon contains 90% of its mass by carbon. Okay? So what is the empirical formula? Is it A, CH2, B, C3H4, C, C7H10, or D, C9H10? Okay, so there's lots of different ways of how you can approach this kind of question. Okay, but for me, one of the more simpler methods to approach this is by making a few assumptions. So because the hydrocarbon contains 90% of its mass by carbon, then let's assume that the hydrocarbon has a mass of 100 grams. Okay, so assume 100 grams. So once we've assumed that it is 100 grams, then means that 90 grams is comprised of carbon, while the remaining 10 grams is comprised of hydrogen. Okay, so in this case, 90 grams, 10 grams. Okay. Now, in empirical formula, we always want to deal with moles in order to deduce the empirical formula. So how do we do that? So 9 divided by 12.01 grams per mole, that's the relative atomic mass of carbon. No, sorry, molar mass of carbon. And then 10 divided by 1.01 grams per mole, that is the molar mass of hydrogen. Okay? So here, see the thing about empirical formulas is that there's not necessarily an exact value unless the example is really nice to use. So what we tend to do here is just we need to make approximations as to approximately what value would that give, what integer would that give. So in this case, so 10 divided by 1.01, since 1.01 is very close to 1, so we could just say it's 10 divided by 1, so this would be 10, okay? And then 90 divided by 12.1, or you could say just divide it by 12, would be approximately somewhere between 7 to 8, more specifically 7.5. Sorry, that was Mr. Benton over here. Hey, you want to come in and join?
Put the lights on, you can see where you're going, you can't see.
Yeah.
Hello, this is Wesley. What a legend this man is. Will be sorely missed from South Island School. Is he making a difference? 4 years. With Empirical Formula. Great stuff. Yeah. Cool. I'll leave Wesley now to talk you through the final stages of Empirical Formula.
Yeah. So that was my chemistry teacher, Mr. Benton. Yep. Thanks. So you might not think that this is a rational relationship because it's a decimal to a full number. But if you think about it, if you remember back in I think it was around sometime in primary 6, you might have learned the concept of landmark numbers, such as the numbers of 25, 50, 75, 100. So if all the landmark numbers were divided by 10, then that means 100 is divided by 10, which equals to 10, and then 75 divided by 10 would be 7.5. Okay. So in a sense, you can think of this as 3/4. So we would simplify this to further 3. That's 4. Okay. So and thus, because the ratio between carbon to hydrogen is now 3 to 4, and thus the answer would be B. Okay? Thus the answer would be B, C3H4. So that is the empirical formula of this question. Okay, so everyone get that clear? So let's do this next one over here. So, what is the empirical formula of a compound containing 50% by mass of X, notice the relative atomic mass is equal to 20, and 50% by mass of Y, where the relative atomic mass is equal to 25. Okay, so is it A, just X and Y? Is it B, X3, Y2? Or is it C, X4, Y5? Or D, the other way around, X5, Y4? Okay, so in this case, because the percentage is still added to 100%, we can still make the assumption like we here. Assume that this compound is 100 grams. Okay, so assume 100 grams. Okay, so that means 50 grams of it is X, while the remaining 50 is Y. Okay, so then here I'm going to use the relationship here again between molar mass and mass of a substance. So that's 50 grams divided by, so this is for X, so divided by 20 grams per mole. And then for here, for Y, because it has a relative atomic mass of 25, and that's divided by 25 grams per mole. Okay, everyone get that clear? So we're just gonna fix the ratio here. So 50 divided by 20 is approximately 2.5, while 50 divided by 25 is equal to 2. So if we multiply both sides by 2 now, okay, actually wait, let me just put the ratio here just to be sure. Okay, so we multiply both sides by 2 now, then 2.5 multiplied by 2 is 5, 2 times 2 is 4, and thus the answer would be D, X5, Y4. Okay, does that make sense right there? Okay, so I'm just going to run out this board now. I'm going to try a harder question, one that would require a calculator, so just get yourselves a calculator ready while I clear up the board.